Okay, good afternoon. Myself D Venkata Ramana. Today I want to explain a topic is Darlington circuit, which comes under high input resistance transistor circuits. It is under the course of electronic circuit analysis. First, we have different configurations like CE, CB and CC. Out of all, CC configuration offers high input resistance. If you want to get more resistance than CC configuration, there are some alternate circuits. In that, the first one is Darlington circuit. Today I want to discuss about what is Darlington pair and how to find input resistance and overall current gain of Darlington circuit. So first, Darlington pair is a combination of CC-CC amplifiers. CC-CC amplifier means we will take two transistors in common collector configuration. Here, the collector terminals of both the transistors are connected to the power supply plus VCC, and load is connected to emitter terminal of second transistor. Consider output is taken here, and input is given to the first transistor. This is called Darlington pair or CC-CC amplifier. In this, actually my intention is to find out overall input resistance. Consider it is Ri1, input resistance of first stage. This is Ri2, input resistance of second stage or simply CC amplifier. To find out, first we need to find out Ri2, then Ri1. We will compare Ri1 with Ri2. Means Ri2 is nothing but input resistance of CC amplifier. Ri1 is input resistance of Darlington pair. First, to find out Ri2, actually my intention is to determine overall current gain and overall input resistance. To do both, first let us focus on second stage. To find about Ri2, first consider H0E multiplied Re, which is less than or equal to 0.1. By suitably selecting Re value, we can make this condition is satisfied. So approximate analysis is valid. When approximate analysis is valid, we know the formulas for current gain of exact analysis, that is minus HFC by 1 plus H0C ZL. Here in the place of ZL, Re is there, and input resistance or input impedance is HIC plus HRC AI ZL. These are the formulas for current gain and input resistance of CC amplifier for exact analysis. When approximate analysis is valid, means we can neglect H0C ZL term. So current gain of CC amplifier is going to be minus HFC. This is consider AI2, current gain of second stage. And input resistance, coming to input resistance, this is HIC plus AI we can substitute as minus HFC, and ZL is RE HRC as it is. But here HRC value is approximately equal to unity, and the relation between HFC and HFE is HFC equals to minus of 1 plus HFE. This is the relation. So by substituting all, we will get Zi equal to HIC plus minus and minus gets cancelled, 1 plus HFE of RE. One plus HFE of RE. Here 1 plus HFE RE term is very much greater than HIC. So we can approximate it to 1 plus HFE RE. Actually this is the input resistance of CC amplifier or second stage. Now we need to verify input resistance of first stage, whether it is greater than the second stage or less than or equal. To do so, here current gain is also minus HFC, which is equals to 1 plus HFE. Now going for the analysis of first stage, we need to verify whether approximate analysis is valid or not. To do so, we will calculate H0E multiplied load resistance of first stage. Here the load resistance is nothing but input resistance of the second stage. So RI2 behaves like a load resistance for the first stage. But RI2 value is very high, which is nothing but 1 plus HFE multiplied RE. So whatever it may be the value of RE, this H0E multiplied RI2 will not be less than 0.1. So approximate analysis is not valid for the first stage. So obviously we need to go for exact analysis for the first stage. If you want to go for exact analysis, again the formulas are AI1 equal to minus HFC by 1 plus H0C. ZL is the formula, but here ZL is minus HFC by 1 plus H0C. In the place of ZL, we have RI2, input resistance of CC amplifier. By substituting RI2 here, that is minus HFC by 1 plus H0C, where RI2 equal to 1 plus HFE of RE. This by expanding minus HFC by 1 plus H0C RE plus H0C HFE RE. In this, H0C multiplied RE term is negligible, which is less than or equal to 0.1. Already we have assumed in the analysis of second stage. So it is minus HFC by 1 plus H0C HFE RE. We can write H0C as H0E if you want. And minus HFC is nothing but 1 plus HFE. 1 plus HFE by 1 plus H naught E, because H naught C, H naught E values are same. To have a uniform representation, I wrote H naught C like H naught E. So 1 plus HFE by 1 plus H naught E HFE RE is the current gain for the first stage. Now similarly, if you want input resistance of first stage is ZA1 equal to HIC plus HRC is already 1, AI1, ZL is RI2, it is ZL. So ZI1 equals to HIC plus AI1, already we obtained AI1, which is equal to 1 plus HFE divided by 1 plus H naught E HFE RE and multiplied with RI2, which is equals to 1 plus HFE of RE is RI2. Here also this HIC term is negligible compared to this term. So input impedance of Darlington pair is 1 plus HFE square multiplied RE by 1 plus H naught E HFE RE. This is the input impedance of Darlington pair. And if you want overall current gain, that is the multiplication of individual current gains, where AI equal to AI1 multiplied AI2, which is equals to 1 plus HFE square divided by 1 plus H naught E HFE RE. This is the overall current gain. So from these two equations we can observe that current gain of CC amplifier is lesser than the Darlington pair, and input resistance of Darlington pair is greater than CC amplifier. So Darlington pair not only increases the input resistance but also increases current gain. Okay, this is about Darlington pair. Thank you.